Well, welcome everybody. It's great to see you again tonight. We're excited to be here. We're continuing this study of Noah's Ark and the flood. And I mean, if you really think about it, if the flood is true, if we can look at the geology and everything about the flood, and we can say, yes, here's evidence for how the flood could have happened, all of a sudden people say, maybe there is something about the Bible that's true. Maybe I'm poking enough holes in the foundations to say, to have somebody conclude, I've got to think about something else because my foundation is weak. And we as Christians, we have to destroy the other foundation instead of letting them destroy our foundation. Because when the foundations are being attacked, what will the righteous do? And so we're commanded to be able to give an answer. And really, when we look at just two basic ways to understand the geologic column, there's the uniformitarian principle, and I've talked about that a lot, and there's the catastrophism principle, or the catastrophe theory. And it's important that we understand both so we can make a cogent argument, but it's critical that we compare both to see which ones make the most sense. So that's what we're going to try to do. We're going to look at several pieces of evidence of the flood in geology. So this is geologic evidence for the flood, and we're going to listen as the stones cry out, and we'll see what kind of evidence points to supporting which theory. That's our goal for tonight. So I'll start with a little bit of history because there's a lot of misconceptions about the geologic column and the rock layers. And so it helps us to understand where that geologic column concept came from. And it starts with this man, Nicholas Steno, in the 1600s. And he, by and large, is still referred to as the father of modern geology. He was the one that developed this concept of stratigraphy, or this mapping of the rock layers, and explaining how the rock layers are where they are in this geologic column. He actually set forth the rules that modern scientists still use, modern geologists still use, in their field research. So this is still going on. His concepts of stratigraphy is what it's called, are still going on. And it's interesting because he based his reasoning on the biblical account of the flood. And he also believed that the earth was only about 6,000 years old. So think about that. The father of modern geology still, and we're still using his rules, was a Christian and he believed in a young earth. Where did we go wrong? So we're going to look at some other theories, and we've talked about this, right? The uniformitarian theory by a geologist, Scottish geologist, Charles Lyell. And I've talked about this a lot, so you all should be able to tell me what the principle of uniformitarian theory is. Anybody want to volunteer? Adam.
That what's happening now, what we can see happening now happened in the past.
Yes, exactly. What we see happening currently is the same process that happened in the past. Only present-day processes of geological change at the present-day rates of intensity and magnitude should be used to interpret the geological column. What's another word for it? The present is the key to the past. Very good. Very good, Adam. And he's only attended once before. That's awesome. And then we have the catastrophe theory. And the principle of catastrophism says that there were rapid, very high energy events that happened in a very short period of time that really caused all this geology that we see. Now, the Genesis flood is obviously that watershed event that really shaped the landscape. Outside of those post-flood events like, volcanism, earthquakes, local floods, and those things. But by and large, what we see with the mountains and valleys that have carved, by and large, all of that, as a creationist, we would say, was a result of the flood. So we're going to look at some geologic formations again to see which one of these two makes sense. And the first one we're going to look at is called transcontinental rock layers. For more than 50 years now, geologists have recognized that sedimentary rock layers in canyons and cliff faces, all of that belong to really what we call 6 megasequences. And a megasequence will explain this. A megasequence is basically a layer or several sedimentary layers. And they all basically have the same characteristics. They start at the bottom with what's called conglomerates. Those are the bigger rocks and the stones. And then as you move up, the sand grains become smaller and smaller and smaller until you get the limestone slurries, which are very fine material. Now each one of these megasequences, all these layers represent one megasequence. All these different layers. And each one of them is bounded on the top and the bottom by what's called an unconformity. Don't let that scare you. It just means that the layer above it doesn't conform to the layer below it. And those are generally erosional boundaries between megasequences. And the megasequences that we see are the Sauk, the Tippecanoe, Kaskaskia, Absaroka, Zuni, and the Tejas. Now think of these megasequences not as separate events, but they're chapters, if you will, of Noah's flood. And the reason that they're graded this way, think of this as a tsunami wave comes in over the continent. The water is rushing over initially very rapidly. Rapid water carries big items. So that's why all of your large particles can be moved by fast-moving water. As that water slows down, then it's really, you're just talking about gravity settlement on these other layers. Much like we talked about last time, where you take your big jar of dirt, and you just put scoops of dirt in there and fill it with water, and you shake it up, and the heavier particles settle to the bottom, and your silts and everything at the top. So think of these, each one of these is kind of a separate jug that you're shaking up here. So it's interesting because rock data from around the world says that all of these sedimentary layers were deposited by water. All of those point to that. And the worldwide exploration of oil has given us a very detailed look at the crust of the earth. During the early 1980s, the American Association for Petroleum Geologists undertook a massive study. They have taken core holes all across the United States to explore for oil. And so what they did is they took all of those cores and they lined them up according to these megasequences, and they were able to map out the boundaries of the extents of each one of these megasequences. Does that make sense, everybody? So this is results of their studies. The Sauk megasequence was that first layer that was laid down. You can see the extents of that, and we're just looking at the United States here. Obviously, it extends into Canada, and we see these same things across other continents as well. But you have the Sauk megasequence, the Tippecanoe, Kaskaskia, the Absaroka, and Zuni megasequence, and it's difficult to find the Tejas megasequence across the United States, but 5 of the 6 megasequences are here, right on the United States continent. So for geologists that believe in a local flood, I mean, what do you do with this, right? This is a major problem if they think that all this just occurred by local floods. So this chart here shows several things. On this left-hand side, these are the typical sedimentary layers that you see in the evolutionary textbooks, right? Starting with the Precambrian layer, the Cambrian layer, Ordovician, and we'll go up the list, Triassic, Jurassic, Neogany. Those are what we see in the textbooks. So on the right-hand side are the mega sequences that we're talking about, right? And if you can imagine this middle portion rotated 90 degrees clockwise, that represents the relative sea level depth. And this is based on a creationist flood model. But based on this flood model, you should expect to see a correlation between the depth of the water and the amount of sediment that was deposited. Does that make sense, everybody? So when you look at these, think of these as tsunami waves in 6 different sequences sweeping over the continents. So initially you wouldn't expect to see a lot of sediments, but then as the water level increased to the height here that is supposed in this Zuni mega sequence, that would be where we would say the height of the flood. And then after the flood, where the mountains were raised up and the waters were running off, you would expect to see the water level falling and less sediment deposits then. So that's the model. Let's see what is reality, shall we? These are layer thicknesses of these mega sequences, and these are averaged across all the continents. And these thicknesses are in miles. So we're talking deep sediment layers. The Sauk megasequence is about 3/10 of a mile thick. The Zuni is over a mile thick. Grand Canyon is about a mile deep, right? So that kind of gives you an idea of what a mile's worth of sediment is. But these layers are huge, especially across other continents. And just as we would expect from the model, if the flood waters correlated, the depth of the flood waters correlated with the thickness of the sediments, we would see a peak of the flood waters here, which creationists would say is about day 150 of the flood. That's when the flood waters reach its maximum, and so it's dumping and settling out most of the sediments. And then it starts dropping off as the water is running off and the sediment is going back into the oceans. This is based on average surface area, the amount that it's spreading. So you can see again the same kind of peak at the Zuni megasequence, but note here between the Absaroka and the Zuni, a lot of creationists believe that could be day 40 of the flood, when the ark first lifted off the ground. There was enough water to lift the ark off the ground with all the weight to be buoyant. And it's interesting because what we see between the Absaroka and the Zuni were the first major coal seams and the first major grouping of numerous land animal fossils. And this is true across the globe. So this correlates very well with the creationist viewpoint and not millions of years of slow, gradual erosion and deposition of sediments. Now, here's just a portion of the Grand Canyon, and within this shot alone, we can see 4 of the mega sequences. Down below here, this is what's called the Great Unconformity. I'll talk about that a little bit later. But here's the first sequence, or what we call the Sauk megasequence. Again, there's an erosion boundary unconformity on the top and the bottom, and then the Tippecanoe, the Kaskaskia, and the Absaroka. And obviously, these layers, the depth and the breadth of them vary from place to place, but what the graph that I showed you was averages over the entire continents. So within each of these megasequences then, scientists have named the other sedimentary layers so we know what they're talking about, we can cross-reference them. And so I'm going to focus on a couple of those tonight. One is what's called the Coconino sandstone, which is high in the Absaroka megasequence. And the other one is the Tapete sandstone, which is the very first sedimentary layer above this, what we call the Great Unconformity. And here's a close-up look of the Tapeats sandstone layer where it meets with this unconformity, what we call the great unconformity. A lot of people believe that this was down here, this was originally sedimentary rock layers, but they were metamorphized. They were heated and pressure, and that changed them into metamorphic rock. And so a lot of people think that those are the original crystalline basement rock of creation. And so what we see then, this boundary here that's not smooth, but then these layers are relatively flat as they've been laid down. Now, this is the extent of the Tapeats sandstone deposits in the United States. But we see these, it extends up into Canada, over into Greenland, England, and then it extends as far down as Israel and North Africa. So these aren't just layers that are just spread across the United States. These are sediment layers that are spread across continents. And we know they're the same layer because of the fossils that are found in them. Now, unfortunately, other scientists in other parts of the world were studying these at the same time we were, unknowingly, and so they gave them different names. We call it the Tapeats sandstone, but in Israel they call it the Nubia sandstone. But they're the same rocks, they're the same deposits that appear in the exact same layers in these megasequences, and they have the same fossils in them. So even from an index fossil perspective, on an evolutionary standpoint, if they have the same fossils in them, it's the same rock layer. And they'll say it's the same age. And we would agree, but just a different principle of, instead of, again, a record of when animals lived, we would say it's a record of where they died as they try to escape the rising floodwaters. So that's the difference that we're talking about. Here's this buff-colored coconino sandstone that's found higher, and the average thickness of just this layer is 315 feet. And it covers an area of at least 200,000 square miles, and it contains 10,000 cubic miles of sand. That's a lot of sand. And this is the boundaries of the coconino sandstone into New Mexico, Texas, and it extends out into Kansas, but again, covers a very massive area. So a local flood is not responsible for this. We also see chalk beds. These happen to be in England, southern England, the White Cliffs of Dover. Everybody's heard of the White Cliffs of Dover, right? However, those same chalk beds are found in Northern Ireland, across Europe into France, Germany, Poland, the Netherlands, Turkey and the Middle East, Israel, Egypt, and even the Midwest from Nebraska to Texas and as far south as Australia. Massive amounts of sediment that are easily recognizable. I don't know if everybody's ever seen the chalk beds, easily recognizable across all the continents. So we'll step into sedimentary layers that are transported long distances. There's evidence that indicates that some of these sediments not only were transported across the continent, but also within the continents. And there was no evidence of that coming from either the rocks below or above. These were brought in from large distances. And they're confirmed by what are called water current direction indicators, or what's called paleocurrents. And here's an example of a paleocurrent. These tell the direction that the water was flowing at the time these sediments were deposited. These are called crossbed sediments. We'll get into explaining those more, but the direction of the water flows from the top left and dips down to the bottom right. That's distinctive of crossbed sediments. They're basically migrating sand dunes. So we'll zero in on those a little bit more. These are ripple marks. And ripple marks, you can tell the direction based on whatever the shorter face is, that's the downstream side. So for example, this is the upstream side, and then the downstream side is this more vertical face. So every time you see these water ripples, you know which direction the current was. Now it's interesting because there's more than 500,000 measurements of these paleocurrents taken all across the United States, over almost 16,000 different areas. And they all indicate that the water flow was from the northeast to the southwest, almost uniformly across the United States. So even modern scientists will say, yeah, all these currents indicate that they're going the same direction. Now, if they were all individual local floods, isn't it interesting that they just by chance would be flowing all the same direction? But these point to, again, a mega event where everything was flowing across the continent from the northeast to the southwest. And so then when you look at these transported sediments, we've got some examples that are really easy to trace. The distinctive white grains in the coconino sandstone, the buff-colored sandstone, they're white quartz crystals. And so you can trace those easily. So we see those white quartz crystals in Grand Canyon, but we also see them up here in Utah and Wyoming. What about the Navajo sandstone? The Navajo sandstone has mica particles in it, and they are radioactive. And so when you see those, we can find those also up in Pennsylvania, New York, all up in the Appalachian Mountains. And that is an 1,800-mile journey to be deposited in Grand Canyon. Now the explanation from the evolutionists are, well, there was once this ancient river that flowed, and so it brought that sediment one sand grain at a time, and it deposited it here in Grand Canyon. There is no evidence of a lake or an ancient riverbed, and we've got this huge boundary problem with the mountains that river had to go over to be able to dump those. But if it all happened during the flood, before the mountains lifted up, we have an answer for that, right? So it's just amazing, again, to see the evidence. Erosion between rock strata. Now, I mentioned there was erosion between the megasequences, but what about erosion between those layers within a megasequence? We don't see any. And this is in the Badlands in South Dakota. And note these, these are knife-sharp edges between these sediment layers. And you can see those distinctively, and they're flat. Now, if these were laid down millions of years between layers, what would you expect to see? You'd expect to see some gullies cut into the previous layer and then filled in, and erosional features again on top. You wouldn't expect to see these knife-sharp edges of sediment. But that's what we see. Look at this. This is in the Grand Canyon. This is the Coconino Sandstone again, and the Hermit Shale. Notice that flat boundary. It looks like it was photoshopped or machined smooth, right? This is the boundary layer that you see all across the Grand Canyon between these two layers. Where's the millions of years? Because evolutionists say there should be 5 to 10 million years of missing rock strata between these. If there were, you'd expect to see gullies and all kind of erosional features cut into the Hermit Shale, and this stuff just stacked on top of it from the Coconino. But again, we don't. So our next evidence is we have rock layers that are tightly bent. Now what happens when you bend rock? It breaks. When you take a piece of rock and you bend it, the bottom layer is in compression and the top layer is in tension, so it cracks because rock is brittle. And so when you see these type of formations where you have these rocks that are bent, you should expect to see fracturing at those places where they bend. These layers supposedly were laid down over millions of years. That rock should have been solidified by then so that it cracks. But they're not. And the only way you can form these layers without cracks is if they are formed when they're still relatively pliable during the flood, before they had a chance to set up. Here's some other ones in the Grand Canyon, and these are people for scale, so these are massive, massive layers. But look at these, they're bent almost at 90 degrees. And yet there's no fracturing in these rock layers because of bending. You see on the surface here, there's some cracking because of spalling, but by and large, there is no cracking on that surface of the rock. So again, these would have had to have been bent and folded during the flood before they had a chance to solidify. Does that make sense, everybody? So, who's all been to the Grand Canyon before? A lot of people. Gosh, almost everybody. Who's walked down into the Grand Canyon? I wish I could say I did. That's on my bucket list. I'd like to raft the Grand Canyon. It'd be awesome. In the Grand Canyon, there's a feature called the Kaibab Plateau, or the Kaibab Upwarp. And that is supposedly based on all of these different sediment layers, Tapete sandstone, Bright Angel Shale, Wabi limestone, all these, according to an evolutionist, would say that's over a 300 million year period that those layers were laid down slowly, one sand grain at a time. And then, 70 million years ago, there was this uplift, and it warped this layer, and so after about 300 million years, you'd think that rock would be hard, right? Again, there's no cracks, and this Kaibab Plateau is huge, and I'll show you some pictures of that later. And I will say, almost every scientist, every evolutionary scientist believes that all of these layers were laid down flat initially and then lifted up. I'll come back to that. Crossbed sediment. Remember we talked about the cross-bedded layers? This is normally, when sediments form, the layers are flat, right? Uniform and flat. In a crossbed sediment, you can see these are parallel, but they're at an angle. That's not because of any uplift, that's the way they formed. That's due to a migrating sand dune. And it's interesting, and I find this fascinating, because you can tell whether these sediments were laid down in air or whether they were laid down in water, and all you need is a protractor. Let's see why. If I took a bucket of sand or any sediment and I dumped it on this table, it would slope naturally based on the granules in the material, and it would form a slope. And the angle of that slope with the flat surface that it's on is called the angle of repose. Right? There won't be a quiz on that, but that's what we refer to it as, the angle of repose. And every sediment has something different. Wet sediment and dry sediment are different. Who's built a sandcastle? You can get sand to stand up pretty much vertical when it's wet, right, at times, okay? So, dry sand has an angle of repose of anywhere from 30 to 33 degrees. That's this angle that face forms with the flat surface that it's on. Almost universally, any sand will have a 30 to 33 degree angle of repose. And this is how the crossbeds form. You have a sand dune, and the wind sweeps the sand up the face of the dune, and then it drops it on the leeward side or the downhill side. And so when that happens, this sand just naturally floats down and forms based on that angle of repose at anywhere from 30 to 33 degrees. It's interesting that when this is underwater, when sea currents are doing this, this angle is always less than 25 degrees. Everybody got that? That seems pretty easy science, right? I think I can go out and measure something and see if it's 30 or 25 degrees. This is in Zion National Park. Massive landform, and you can see these crossbed sediments. The sand dunes, the wind or whatever, water, swept up the face, deposited the grains down here. Now, when it's in water, they're always less than 25 degrees. That's because the water provides a cushion and it suspends the particles, and so they don't stand up flat like you would if you would pack them together, but they're suspended and they gradually sink. So that angle should be less. Anybody have an idea of what that angle could be?
25 degrees.
It's less than 25 degrees. It's around 18 degrees. So what does that tell us?
Water.
It was formed in water. Fascinating evidence for a global flood because we see these cross-bedded sediments on major landforms. I was excited when I saw that.
Is there, so if it's always less than 25, the lower the angle, does that mean the water was moving even faster?
Yeah, that's a good question. So the answer is, it's always less than 25 degrees. Does that mean that the water was running faster? It's very possible because it was kind of shooting up over the top, and then it carried those particles a little bit farther downstream, so it flattened those out. Yes, great
I
observation.
just asked that because the previous one you did was like 22 degrees.
Yes, yeah, if we look back at this other one, yeah, that's about 21, 22 degrees on that particular one, so slower water probably flowing over that. Great observation. So let's move into coal bed deposits then. Coal beds are found all across all countries. The USA has more than 7 trillion tons of coal reserves. And we have similar huge deposits in other locations like Canada, China, Australia, Africa. Coal beds are everywhere. And it's interesting because each coal bed may range anywhere from inches thick to feet thick. And many people say that if you took all the vegetation that's on the earth today and you formed that into coal, that you would only have 3% of the Earth's current coal reserves. So that tells you the massive amounts of vegetation that were buried and coalified during the flood. And we think we've got a lot of coal now. What kind of vegetation was there before the flood if we only have 3%, right? Massive amounts of vegetation. Now scientists will say that coal forms in peat bogs, and that generally it takes 10 feet of peat to make 1 foot of coal. And they see that now occurring very slowly. So the uniformitarian principle says, well, it's been doing that for millions and millions of years. So coal beds are supposed to be millions of years old. When we get into dating rocks and fossils, we'll show you that the methods that they use are in air, and we'll figure out how to date carbon. And diamonds are dated, or I should say diamonds are carbon, and we can still find carbon in diamonds, and we can still date them with carbon-14 dating methods, even though you should be able to date rocks by carbon-14. So that'll tell you something about the age of diamonds, but we'll get into that more when we talk about dating fossils and rocks. Now, when you look at these coal beds, they're generally very flat on the top and the bottom, and there's generally clay layers between them. And that's almost universal when you see these coal deposits. Now, if these were formed by trees that grew in these peat bogs and they lost the bark and pine needles or leaves or whatever, it means trees were growing in these peat bogs. So why don't we see evidence of tree balls, root balls, penetrating into these clay layers below? You would think that if trees grew there, you would see some evidence of coalified layers kind of seeping down where these root balls are, but for some reason, we just see them flat. So it seems to make sense then that if the plant material was already dead, and it was swept up onto the continents with these ocean currents, and these plant materials kind of settled in the low-lying areas and more sediment got piled on top of it, that these would settle out into flat layers. Again, I think that's evidence for a worldwide flood. Rapid Canyon Formation. This is the Glen Canyon Dam, and it was completed September 22nd, 1966. And at the beginning of June of 1983, this dam almost failed. And there were unexpected warm rainfalls that occurred in the mountain areas, and it melted the snow very rapidly. And they were having flooding problems upstream, and so the engineers of the dam decided to open up the 4 spillways to let the water out and to ease the flooding upstream. When they did that, they released 93,000 cubic feet of water per second out of the 4 spillways. That wasn't enough, so they were going to crank up all the spillways. They cranked up one to 32,000 cubic feet per second. And all of a sudden, the dam started to shake. They saw chunks of concrete and rock, and the water started turning red-brown. They cranked the valves shut as fast as they could, and this is what they found. 3-foot steel reinforced walls were cut away from this dam, this spillway. It cut a hole that was 32 feet deep, 40 feet wide, and 150 feet long. Scientists estimated that it was eroding about 1,000 cubic feet per minute through solid reinforced concrete and solid rock. That's a testimony to what fast-moving water can do. So if it can do that for this dam, why can't it do it for Grand Canyon? So was it formed by just a little bit of water over a long period of time, or was it formed from a lot of water over a little bit of time, cutting through solid rock? I think it was formed by the flood of Genesis, a lot of water over a little bit of time. And here we see, this is your general picture of the Grand Canyon. It's a widely visited tourist attraction, and it's probably one of the largest erosional events, the deepest one certainly, that we have in the United States. It's 277 miles long, including 60 miles of what's called Marble Canyon, which is at the northern end. The depth varies between 3,000 and 6,000 feet. The rim-to-rim distance varies from 4 miles to 18 miles. It's interesting, the river elevation upstream where you drop your raft in, if you're rafting the Colorado River, is 2,800 feet above sea level. The downstream where you pull your raft out, after you've gone through the canyon, is 1,800 feet above sea level. 1,000-foot drop during that span of 277 miles. Here is a digital relief map of Grand Canyon. This is the Prime Canyon right in through this area. The dark green areas are elevation or areas of lower elevation. The light green areas are higher elevations. And the real light area here is the highest elevation in the canyon. That's the Kaibab upwarp. And most evolutionary scientists will say that that upwarp occurred before the Grand Canyon formed. What does that mean? That means this Kaibab upwarp is at anywhere from 6,900 feet to 8,500 feet above sea level. The river upstream is at 2,800 feet above sea level. In order for the Colorado River to have carved the Grand Canyon, the river would have had to have flowed uphill. And you can ask any evolutionist or long-term geologist, long-age geologist, and they don't have an answer for that. They've got a lot of theories, but no solid answers. So from a creation model standpoint, we would say, and there is evidence for these ancient lakes upstream of the Colorado River. There's geologic formations that would indicate that there were lakes. And they gave them the name Uinta, Canyonlands, and Hopi Lake. And the thought is that as the water was running off the continents, when God was raising up the mountains, that this Kaibab plateau was lifted up and it trapped the waters behind that plateau. And there's enough water here, supposedly 3,000 cubic miles of water retained behind that Kaibab upward. That's 3 times the volume of water in Lake Michigan. Massive amount of water that was backed up because of this upwarp when the water was running off the continents. So it seems to make more sense from a creation perspective that these lakes formed behind this upwarp. Now, the upwarp is made primarily of limestone. And what do we know about water and limestone? It erodes. It's very erosive. We have...
It's very soft.
Yeah, it's very soft. And so we have sinkholes, right? Florida just had a whole bunch of sinkholes where, I mean, houses were falling in because they were built on this limestone layer that was wet, and they sunk down into this huge hole. So if these lakes were eroding this limestone fairly rapidly, and it broke the dam, you would create a huge chasm. And then later, when Canyonlands ate through the dam, it created the Marble Canyon, and now the Colorado River is flowing through the canyon. It didn't create the canyon. Does that make sense? So here again, this is a USGS map, United Geological Survey map, and you can see this Kaibab upwarp and this canyon cutting right through it. Now there's something else that's kind of unique when you look at this. You see these barbed canyons here? They're coming off downstream. Some of these have rivers in them, very few do. How does the Colorado River flow from north to south and create these barbed canyons? The water would have had been flowing the other direction to carve these barbed canyons out. So the theory is that when these lakes drained, all the water kind of ran to the center of this valley, and the water rushed into this lowland, and it cut these barbed canyons. You can't get that with the Colorado River forming these barbed canyons by flowing from north to south. Just wouldn't happen that way. Now, we mentioned the Precambrian basement rock. This is the Tapete sandstone layer that's all highlighted in yellow. And we see that all this crystalline basement rock, again, it was once limestone, but now it's metamorphic rock. And you can see the river was erosive enough, or when the water drained off, it was erosive enough to cut through this metamorphic rock, just like it cut through the dam. And here's a cross-section of the Grand Canyon, and the red line represents that great unconformity. All the layers above that are flood layers. They were all formed in water and deposited in water. This group of layers down here are called the Grand Canyon supergroup. And notice how they're all kicked up. They're up on one side. They've been uplifted. And the creation model says that when the fountains of the great deep broke forth, there was an upwarp, or a thrusting up of these rock layers, and then it wasn't totally flat, but we'll show you a picture of those, relatively flat, and those first waves that came in very rapidly planed that surface off. So you would normally see these rock layers extending further up, but those erosive waters from the very first shaved all that layer off to a flat plain and carried it out to the oceans, which then later was swept up onto the continents and dumped as sediment onto the continents. This is a picture of the great unconformity. Here's the Tepete sandstone layers up here, and this is that crystalline basement rock, what a lot of people call that Precambrian layer. There's very few fossils in the Precambrian layer, and isn't that what we would expect during a global flood? Now, remember last time we talked about the scabland area. This is the area that's starts in Idaho, crosses the southeast corner of Washington State and Oregon, and all the way to the Pacific Ocean. Now there's evidence here that this was a large-scale flood that carved this out. And there was a man in the 1920s, his name was Harlan Bretz, J. Harlan Bretz, and he was the first one to postulate that this maybe was a little different than small little stream erosion over millions of years. But at the time, he didn't have a water source for it. But there was a conference in Washington, D.C. in 1927, and Bretz knew a lot of big-name geologists were going to be there. So he thought, well, this is my opportunity to present my case and to be really, here's my career of being a world-renowned geologist. So he presented his case in full based on this evidence that he sees out there. And unfortunately, one by one, all these prominent geologists stood up and denounced him. And they all came up with these different theories of, yeah, this is just, slow millions of years of gradual stream erosion. But Bretz knew this wasn't gradual stream erosion. 500 foot of this solid basalt lava was cut through, he believed, in just a matter of days when this Police Falls and Palouse River Canyon were formed. This was one of the statements that one of these scientists said that attended the lecture that he gave. He said, I am naturally loath to accept a theory of an abnormal flood for the scablands farther east. Before a theory that requires a seemingly impossible quantity of water is fully accepted, every effort should be made to account for the existing features without employing so violent of an assumption. Why is that? Because they'd have to acknowledge that it was a global flood or some large event that caused it. And they don't want to do it. They're loath to even accept that theory. There was another geologist named Pardee that came around later, and he defended Bretz, and he said he'd been studying evidence upstream of this, of some ancient lakes. And he believed that these lakes were possibly formed during the Ice Age, and that could possibly have been the source of the water. And this is an example of upstream in Montana, a possibility where you see these shoreline ripple marks of these massive lakes, and Pardee called this Lake Missoula. So if you've ever heard the flood, Lake Missoula, that's supposed to be this ancient flood that occurred. Now, the thought behind this theory is that during the Ice Age, a finger of the ice came down here and blocked the Clark Fork River. And the river backed up into this huge lake what's called Glacial Lake Missouri. It was about 2,000 feet deep at the dam, the water level was, and about 540 cubic miles of water. That's more than Lake Erie and Lake Ontario combined, so a large body of water that supposedly was formed behind here. Then when the ice dam collapsed, it broke through, flooded out this massive area as the water migrated its way and dumped out into the Pacific Ocean. And remember those paleo currents that we talked about that told which direction the water was flowing? This is a distant picture of these water ripple currents. This is a close-up. These are 20-foot ripple marks, 20 foot tall. And you can see the sharper angle down here, so the water was flowing this way towards the Pacific Ocean. Not just a little local flood here. This was a flood of huge magnitude. Now, in 1965, Bretz was finally vindicated because these same scientists, these same geologists that denounced him earlier, they took a field trip to look at the evidence. And they excitedly, obviously they didn't have texting back then, but if they texted, I'm sure they would have said, hey, but they used telegraph, for you young ones, if you remember what telegraphs are. I don't, thank goodness, I'm not that old. But they telegraphed him and said, we're now catastrophists. They now believe that it was a massive amount of water, not millions of years of slow erosion. Unfortunately, they had trouble believing that there was a flood that would have that much water in it to overwhelmingly wipe out this whole area. It only took 40 years for them to come to that conclusion, though. Although they still haven't agreed that there was once a global flood, like the Genesis flood. So they're still hanging on, but they're getting closer. Every day people see evidence for massive floods, and they're getting closer to recognizing, except for one thing, if they do, they have to admit that the Bible is true, and that this is the accurate account of what we see today. Final, and I'm going to try to wrap up quickly with this, volcanoes. The evidence of volcanoes. Here's a picture of Mount St. Helens in Washington State. This is before the eruption. This is what it looked like approximately 8:32 Pacific time on May 18, 1980. There was a 5.1 earthquake on the Richter scale that triggered this massive explosion. When that happened, lateral material blew out of the side of the mountain at over 300 miles per hour at temperatures of over 600 degrees Fahrenheit. The blast force energy, when you're talking about thermal blast force energy, was 24 megatons. 1,600 times that of the atomic bomb that was dropped at Hiroshima. 1,600 times that blast force energy. It snapped off trees that were there in the forest, stripped the bark off, threw them into the Spirit Lake like toothpicks. Here's a down view looking at it at this geological map. This is Mount St. Helens. The blast came out of the north face of the mountains. This pyroclastic flow of molten material spilled into Spirit Lake, caused massive flooding. The debris avalanche blocked the north fork of the Toutle River, causing additional flooding. And this is the blast zone. You can see the lateral blast. This is about 12.5 miles. This is about 19 miles. You can see even the scorched zone out here where the trees were scorched even beyond that. And the avalanche of the ash fall. This is one volcano. Subsequent eruptions occurred later on June 12th of the same year, and we see all these fine layers, these thin layers that were stacked up, anywhere depth from 25 to 40 feet. This blast occurred at about 9 o'clock at night, and this was all formed by midnight. If you would look at this, if you didn't know what happened out here, and you're just your uniformitarian geologist coming out here, you were told that this formed maybe 2 layers a year. So there's thousands of thin layers, thin laminated layers here. If that's the case, it would have taken millions of years. We know it took 3 hours. Here's another episode that occurred 2 years later, March 19th. Another eruption, and the heat melted the snow and the mud layer, the frozen mud layer, and caused these massive mud flows. Mud flows are very disastrous. When the dust settled, this 1/40th scale model of the Grand Canyon was formed in 5 days. Not through ash that was easily erodible. This was 2 years after the event, so this is hardened rock. A lot of this was basalt lava. 5 days it formed this. This zigzag looks exactly like the formation of the Grand Canyon does in 5 days. Here's another view of the Little Grand Canyon. In some places, this is 140 feet wide, 150 feet deep. Little bitty river trickling through that. If I didn't know what happened and I was a uniformitarian geologist, I'd be walking through here saying, little river, millions of years. We know it wasn't. It was drastic. We know when the event happened. So if you know when the event happened, and you know how devastating it can be, wouldn't you take that same knowledge and apply that to Grand Canyon or other features that we have to say, well, it could have happened quickly then too? Here's another picture of over the next decade. This is called Engineers Canyon. Again, up to 150 feet deep in places. And again, not just that easy pulverized dirt that you can go through. This is through welded volcanic rock. And Lewitt Canyon, doesn't this look a lot like Police Falls that we saw earlier in the Scablands, where you have the nice little waterfall? 100 feet deep, carved out rapidly. So again, we know when Mount St. Helens erupted, and we see the results of it. We see that over 50% of the sedimentation was probably due to these underwater mud flows, these huge mud flows that occurred. We know what carved the canyon. So if the Little Grand Canyon formed in just 5 days, again, a localized event, what does that say for the Grand Canyon? Could have formed very rapidly, and I believe it did form very rapidly, along with many other creation scientists. So by volcanic standards, and you have to forgive me, this slide has all the millions and millions of years from evolutionists of when these other volcano events happen, but this is based on the amount of ash that formed during these volcano events. So when you look at Mount St. Helens, that's a pretty puny volcano. Think of some of these larger ones where, like Yellowstone, I think they said there was 3 volcanic occurrences in Yellowstone, and the ash fall that you can see for miles and miles around there. But think of during the flood. Remember when we said we looked at the ring of fire, those plate tectonics, where that's most of where the volcano and the earthquake action occurs? If there were massive amounts of volcanoes exploding at that time with earthquakes, think of what that could have done. This is one volcanic eruption that we saw in Mount St. Helens. When we talk about the Ice Age, we're going to talk about ash and aerosol stuff in the air and what that does to climate. And you can kind of even think of what the news is telling you on that as well, as far as cooling that occurs when volcanoes explode. So we'll explore that a little bit more, but think of the amount of ash that would have been in the air at that time. I mean, the one in Iceland closed airports for weeks because they couldn't fly, they couldn't get off the ground because of visibility. So here's just a small amount of evidence that we've shown you tonight that point to a global flood that's recorded in Genesis. when we look at the geological record, it points to, I mean, really, you've got two views. You've got the catastrophe view, and you've got the uniformitarian view. We set out today to say which one makes the most sense. Millions of years of time of slow erosion and slow sediment deposition, or are we talking about massive amounts of flood? Now, I know this doesn't necessarily prove that the Bible is true. We have much more evidence in terms of how we can prove the Bible is true, but this leaves really, I think, only one logical explanation. So when you really get serious about looking at this, what observational science tells you, things that we can see and test and duplicate like we did at Mount St. Helens on a small scale, to me, this whole idea that man decides truth and it's millions and millions of years does not make sense when you look at God's word in the global flood. So I think when you look at the evidence, you can only come to one other conclusion, that what we see in the world today is exactly what God tells us in His Word. And that geology confirms that the Bible is true and there was a Genesis flood, worldwide event.